Hello friends, welcome to our Hariharan Express channel. Today our topic is implement higher order multiplexer using lower order multiplexer. Okay, higher order multiplexer using lower order multiplexer. That means how to create higher order multiplexer with the help of a lower order multiplexer. Okay, we have already discussed in a last class when we will create the multiplexers. Very simple example we have already taken, and the types of multiplexer already taken. That kind of basic concept we have already discussed. You see, very simple example, very simple multiplexers we have already considered. Whenever we consider that is different inputs to the combinational circuits of 4-1 multiplexer, we will get one output, and that input select through two selectors, that is S0 and S1. Okay, this is the basic concept we have already discussed for the 4-1 multiplexers. Similarly, we can also design 8 into 1 multiplexer. Okay, or more than that higher order of multiplexers. But think that whenever you will consider any kind of inputs, based on that number of selectors we have to choose. This is the main motto to design the different kind of inputs for the multiplexers. Okay, for example, suppose we choose choose 8 into 1 multiplexer. Okay, suppose choose 8 1 multiplexer. Then 8 is inputs. Okay, 8 is inputs and 1 is output. Okay, then what happens? 8 inputs will provide as a 8 number of inputs provide to the that multiplexers. If 8 number of inputs will provide, actually which inputs will consider as output. Okay, so how to consider that output? That is the one major question whenever we decide, that is which inputs consider as a output. That inputs is considered through selectors, that is we can tell as a selectors. Selectors choose which inputs consider as a output. Okay, so the number of selectors, here the question is how many number of selectors will you choose. Okay, so selectors are choosing through number of inputs. If the number of inputs is increasing, automatically selectors we have to consider accordingly. For example, like if 4 inputs, we will consider suppose 4 inputs, then how many selectors is required? These 4, I will give some instruction, then some trick, then you can find out. 4 inputs is actually every input is designed through 2 to the power n. Okay, and if 2 to the power n inputs is there, then what happens? Here for 4 inputs we can consider 2 to the power 2, where n is equal to 2. That means where n is equal to 2, then 2 to the power 2 is equal to 4. Okay, that means when 4 inputs will consider, then with the with the help of n is equal to 2, and if we found n is equal to 2 or n is any terms, then that n value consider as, we can consider for selector. Okay, very simple example. Okay, if n is equal to 2, how many selectors is required? That is 2 selectors is required for 4 inputs. Okay, if n is equal to 2 as selector, then 4 inputs we can take. Okay, we can take that is 4 inputs. Okay, and similarly if we go through n is equal to 3 as selector, how many inputs will we consider? Okay, how many inputs consider? That is 8 inputs. Okay, like this. So we have to design how many number of inputs we will consider. Based on that, how many number of selectors we will consider. So based on inputs, we will consider selectors, or if selectors is there, automatically how many number of inputs or maximum number of inputs we can consider accordingly. This is the basic concept. We have already discussed how to design the multiplexer, but selectors point of view, how many selectors will you choose, that depend on number of inputs for that multiplexer. Okay. So now you see these selectors is very important for any kind of a multiplexer. Okay. Now see our aim to design, that is implement higher order multiplexer using lower order multiplexer. Okay. For example, suppose we consider like a 8 into 1 multiplexer. For example, 8 into 1 multiplexer we need to design. 8 into 1 multiplexer we have to design using lower multiplexer. Lower multiplexer means normally what happens, multiplexer is defined through 2 to the power n inputs normally. Then if we go through higher multiplexer is 8 into 1, then lower multiplexer, suppose it is considered as a higher multiplexer. Suppose we will consider higher multiplexer. Okay. So lower multiplexer can be designed, that is a 4 into 1. Okay. 4 into 1 multiplexer we can consider as a lower multiplexer. Again we can also consider as 2 into 1 multiplexer consider as a lower multiplexer. Okay. In this way, higher multiplexer, suppose we have to design this higher multiplexer using lower order multiplexer, means with the help of 4 into 1 and 2 into 1, these two multiplexer will help to create 8 to 1 multiplexer. Otherwise we can create 8 to 1 multiplexer, it's okay, doesn't matter, we can create. But using lower order multiplexer we can also develop, that is a 8 to 1 multiplexer. That means 8 into 1 multiplexer, which is higher multiplexer, whenever we will need to design with the help of 4 into 1 and 2 into 1 multiplexer we can also use. This is the basic concept. So for the reason the topic is the implement of higher order multiplexer using lower order multiplexer. Okay. So now we see how it will design. Very simple way. First of all, we see that whenever design this lower order or this order, how it is designed. First of all, we take that. Suppose we have to that is we need to implement 8 into 1 multiplexer with the help of 4 into 1 multiplexer and 2 into 1 multiplexer. Okay. Whenever we go through these two multiplexer, then we just consider as a 2 steps. First stage we consider 4 into 1 multiplexer. Two kind of 4 into 1 multiplexer. Okay, not kind, same category, two times. Okay, 2 times of 4 into 1 multiplexer considered in the first stage. Again, we know that whenever this multiplexer provide output, so only one output we can get it. That means for one multiplexer provide one output, another multiplexer provide another output. Then when that two output will consider, then that output also consider as a 2 input for this 2 into 1 multiplexer. Then it will provide one output. Okay, this is the basic concept. Now see how it will design. Very simple way. How it will design. Very simple way. We will see, that is 8 to 1 design 8 to 1 multiplexer with the help of 4 into 1 multiplexer and 2 into 1 multiplexer. Very simple way. We will design this part. Let us consider that is 2 into 1 multiplexer Okay, one multiplexer design in this way. Okay, another multiplexer also design 4 into 1. Okay, multiplexer. Okay, multiplexer. Okay, so 2 multiplexer we consider. Since we need to design 8 one multiplexer, so how many number of inputs are required? That is 8 number of inputs are required. That 8 number of inputs divided 2 parts. First part divide to 4 into 1 multiplexer. Second one divide to, that is another 4 part divide to 4 1 multiplexers. Now we see, whenever define these multiplexers, then how different inputs are used to this multiplexer. Very simply, you see, very simply I will show you how it is defined. Okay, here is I0, I1, I2, I3. Okay, 4 inputs given to this multiplexer. Similarly, here also we will provide, there is another input, that is I4, I5, I6, I7. Okay, these 4 inputs given to this multiplexer, 4 multiplexer. These four inputs given to this multiplexer. Okay, so these 2 multiplexers can be defined or can be used or can be considered as a here 2 first steps. We can see very simple way. I will show you. These are the inputs. Okay, we can tell as these are inputs. Similarly, here also inputs. How many inputs? 4, here 4. Total 8 inputs are there. Okay, this is the first stage. We can tell as this is a first stage. We can tell as a first stage, this one. Okay, but whenever I go through this one, who will it select these inputs and this input to the corresponding multiplexer? Who will select? Another concept also there, because I have already discussed, whenever go through multiplexer, then we have to consider selectors. That selectors decide which inputs provide to the multiplexers. So 2 selectors we will consider here. Very simple way, 2 selectors we define. Very simple way I will show you. Here is suppose S1 and S0. One is S1 here, okay, and S0 here. 2 selectors will design in this way. Then 2 selectors connected to this 4 1 multiplexer here. Again 2 selectors also connect to this another multiplexer here. But how to choose? We will discuss how to choose. But both should be connected here. Then it will choose depend on that either this multiplexer or this multiplexer. I will tell you that later. First design this block diagram of this multiplexer for 8 1 multiplexers. Now we see this one. Whenever we go through this multiplexer, definite it will provide one output which is considered as input to 2 1 multiplexer. You see, very simple way. I will show you this. This multiplexer. Okay, this multiplexer is considered as, you see, very simple in this way. 1. Another similarly, another concept also we can define here. Another also we define here. Very simple we can consider. Okay. So one output from this multiplexer come to here and another multiplexer also come to here. Then lastly, this is the what last output defined by this one. Okay, that means from this multiplexer provide one output, this multiplexer provide another output. These two output considered as a input to this 2-1 multiplexer, and this 2-1 multiplexer provide that is only one output. Okay, this is the basic diagram. Now we see how to choose actually this input for this 2-1 multiplexer. Now how to choose either this one or this one considered as a output input. Again another concept also there, we can choose here another selector, that is a S2 selector. Okay, we can take S2 selector to choose either this one or this one. So now see very simple way, if we go through normal concept of 8-1 multiplexer, then what happens? How many inputs is required? You see 8 inputs is required. 8 inputs already given, I0 to I7. Very simple way. How many selectors are required? That is 3 selectors are required. So we provide S0, S1 and S2. 3 selectors are also given. But the structure of that multiplexer is different because we have to design the higher order multiplexer using lower order multiplexer. Okay, so with the help of 4-1 multiplexer and 2-1 multiplexer, we have to design that is 8-1 multiplexer. So this is the other way, other concept of that multiplexer. Not directly. If we go through directly 8-1 multiplexer, so simple. One multiplexer by one multiplexer developed through 8-1 multiplexer and 8 inputs is there. One output we can get it. That is the very simple. Okay. But since we defined, we have to define or we have to implement higher order multiplexer using lower order multiplexer, then we have to design in this manner. Means suppose we have to design 8-1 multiplexer as a higher order multiplexer, then that is we can write also higher order multiplexer. So with the help of 4-1 multiplexer and a 2-1 multiplexer in this manner. This is the basic concept to design. Okay, so very simple way. Whenever go through this selector, these selector choose either this one or this one based on this S2 selector. We see very simple way how it is designed, how it is defined. Okay, now we see whenever go through this S2 selector, we know that it has also binary forms or bits number. Like S2, if we go through S2, it has two binary number, that is 0, 1. If we go through 0, then it will choose either this one or this one. If we go to 1, either this one or this one. Like this it will choose. But we design it such a way that whenever we will provide that is S2 value 0 or 1, based on that it will choose this one or this one. If it is 0, suppose it will choose this one, it will be inactive. If it choose 1, suppose here is a 1, then it will be inactive. Okay, depend on that which value or which register defined, which multiplexer defined as per these selectors. Okay, depend on that. If we go through that is 0, for example S2 is 0. If S2 is 0, then what happens? We will consider if it 0 means suppose S0. Okay, this is 0 for example, this is 1. So I0 to 1, 3 or this multiplexer can be activated and passed to the data to Y. Okay, this is the basic concept. Understanding point? Suppose S2 is 0, here is 0, for example this is 0. So obviously it will be 1, for example we can take, or it is 0, this is 1, no, there is no problem. For example we will consider suppose 0, this is 0. If we will consider S2 is 0, that means it is 0, 0 consider means it is inactive. So which one active? This one active. That means if this first stage multiplexer 4 1 multiplexer is activate, so this will receive I0, I1, I2, I3 value, and it will receive to this particular multiplexer. Okay. Again what happens, which value receive again, that value received through S0 and S1, because it is already connected to both multiplexer. It is connected to here as well as connected to here. If it is inactive, this S0 and S1 activate all inputs for this multiplexer. If it is inactive, then this multiplexer will be activated and receive the value through S0 and S1. So either case depend on this, okay, depend on this particular selector. Very simple way. If selector is 0, this is inactive. If it is 1, if it is 0, this is 1 automatically. So then what happens? It will activate. So it will activate means it will receive I0 to I3. Then which value it will receive? That depend on that S0 and S1. This S0 and S1 activate I0, I1, I2, I3. It pass to the one output to this particular multiplexer. It will provide, that is a Y value. Okay, it will provide Y value. This is the basic concept. So on this basic concept also we can consider or we can implement whole different kind of multiplexer. We can tell as it is a design of higher order multiplexer using lower order multiplexer. Okay, this is the basic concept. Now we see very simple way. Now we will draw the that is a truth table or function table of 8 to 1 multiplexer with the help of that 3 selectors S0, S1 and S2. Okay, now we will draw that particular multiplexer, that is a function table with the help of this one. Now we see very simple way how we can consider this one. Okay, now we will see very simple, that a function table. We can write the function table here. Function table for 8 1 multiplexer. 8 1 multiplexer. Okay, we have to design the function table. Very simple way. So how many inputs we can consider? Normally 3 inputs consider as a selector. So selector, we choose the selectors and that is one output. So very simple way we can consider here, like left hand side we write S2. Okay, here is S1, here is S0, here is Y. Okay, now you see how it will be considered. One, two, three, 4, 5, 6, 7, 8. Okay, now see. Now you see we have already discussed, that is S0, this S2. S2 either consider 0 or 1. Okay, either consider 0 or 1. If it is 0, then which multiplexer will be considered? This multiplexer will be considered. And another is here you see, since two type of multiplexer are used, then we can consider 2 stages. One is first stage here, second stage also we can write here. Okay, that is a second stage. First stage 2 multiplexer, that is 4 1 multiplexer. Second stage is only 1 multiplexer, that is a 2 into 1 multiplexer. Okay, in this way we have to consider 2 stages. This is the first stage, this is the second stage. Okay, now we see if we go through this function table, then we see what are the values. So I already told, that is if we go through this S2, we can consider 0 and 1. If it is 0, how many? That all are will be inactive, other part will be active. Okay, So here if we will put 0, then what happens, that 4 part will be 0, because this S0 S1 consider as a one multiplexer. So 4 type of inputs we can give. Again another is if it is 1, same, that is we can also give like this. So here 4 0, because S0, why it is 4 0, because it depend on this S0 S1, it will receive, that is 4 inputs. So 4 0 we can consider, because 4 inputs is generated or is activated by S0 and S1. So 4 0 will consider. Similarly if we go through 1, similarly 4 inputs also considered by S0 and S1. Okay, now we see. So here you see, if we go through this, if it is 0, we got this, or we activated this one, 4 into 1 multiplexer. Then what are the outputs, sorry, what are the inputs and what are the outputs? Inputs are I0, I1, I2, I3. These are the inputs to the particular multiplexer, and it will receive, or it will decide which output we can consider. That decision is designed by, or decided by S0 and S1. So S0 S1 decide which inputs consider for this multiplexer, and as well as consider as a output. So S0 S1 we consider, previously some trick is also there, like S0 0, S0 S1 0, then we consider I0, S0 0, it is or it is 1, it is 0, that I1. Like this we have to design, and by which I0 will consider as input, or I1 consider as input, I2 is considered as input to the multiplexer, or I3 considered as a multiplexer. Okay, like this we will see that which inputs are considered as a these are which one is considered as a input to the this corresponding multiplexer. Okay, you see. So if it is 0, it will be activate. Now we see this value we can define. Here is 0 0, okay, 0 0. Then we can define value will be what? Value will be I0. Okay, 0 0 value will be I0. Then we can also define another way. Here will be, that is 0 1. Okay, here will be 1 0, here will be 1 1. In that case what happens, the value will be I1, because it is 1, both it is 1, it is 2, it is 3, I2, here is I3. This kind of output we can get through this Y. Through this Y we can get this kind of output, where S2 is 0. If we go through S2 is 1, then similar case also we can consider. Okay, that is same case we can consider, like here is also 0 0, sorry, this is we can consider another way, that is 0 0 0 0 means, you see, first part will be over, you see, it is 1 1 means if it is 0 it will be inactive. Okay, if that is 1 it will activate. Okay, if it is 1, this is 1, this is 0, reverse case, then it will activate. If it will activate, then I4, I5, I6, I7 as input to this particular multiplexer. This will be considered to the output of to the particular 2-1 multiplexer, like this. Okay, so if it is 1, then automatically what happens, we consider here like a what, 0 0 0 1 1 0 1 1. Okay, so in that case what happens, result will be what you find, here is I4. Okay, we can take as a, that is I4. Okay, I4, I5, I6, I7. Okay, this 4 plus 4 8 output we can get in this way. Okay, so depend on that, understand my point, depend on that. So don't confuse, because sometimes here we see here is a 0, here is a 1. We can also write here is a 0, here is a 1. No problem, don't worry. Okay, we can write here also 1, here is a 0. Don't worry. Based on that, which multiplexer can receive the output input from here and provide one output. Depend on that. Don't worry either case. So here also suppose S2 0. Here is 0. Then what happens? We consider this one. Okay. That means A0 is activated. Actually what happens? Which one 0? Here you see which one 0. Suppose this is 0. It will 1. So we have to take this one. Okay. If it is 0, it will activate. We take this one. Either case, don't worry. If it written in this manner, doesn't matter. We can also define accordingly. Doesn't matter. Okay. So we can consider this kind of a function table for that is a 8-1 multiplexer. This is the basic concept. I explained all. So you have to design accordingly. Then the question may be arise, design higher order multiplexer using lower order multiplexer. Okay. Particular example may be considered, like design, that is question may be arise like this. Suppose design, for example, question may be like this. Question may be like this. Design, that is 8 into 1 multiplexer using what, that is using 4 into 1 multiplexer and 2 into 1 multiplexer. Okay. So the question may be arise in this way. We can also define it accordingly. Okay. So I think you understand all kind of things. So you see, whenever you define in this way, then what happens? Very simply, last one we got this output depend on this two input. Okay. Again this input also define at the this one output depend on the this multiplexer. Again we will consider this what this 4 inputs. Okay, this multiplexer contains 4 inputs. This also contains 4 inputs. So we consider that is a 2 what stages. Okay, first stage is consider this 4-1 multiplexer. This stage contains 2 second, that is the second stage contains this is 4-1 multiplexer. This contains 2-1 multiplexers. But sometimes some complexity question may arise, like we design that is a 16-1 multiplexer. For example, 16-1 multiplexer. Then how to design? 16-1 multiplexer, suppose we consider, then what happens if we consider this one? You see, 16 into 1 multiplexer, maybe question multiplication, we can write a 16-1 multiplexer. Okay, 16-1 multiplexer with the help of what? That is 8-1 multiplexer or 4-1 multiplexer or 2-1 multiplexer. That question I gave to you. So you can also design how it will design 6-1 multiplexer with the help of 8-1 multiplexer or 4-1 multiplexer or any other. Okay, you think about this and find the solution how it will design. Okay, that means implement of a 6-1 multiplexer with the help of that is 8-1 multiplexer or 4-1 multiplexer or 2-1 multiplexer. You will think about this and find its corresponding solution. Okay, so I hope all of you understand this multiplexer. There is a different ways, simple multiplexers and some higher multiplexer, how it will be designed with the help of lower multiplexers. Thank you very much. Thanks to all to watch my videos, and thank you very much. If you have any comments, you can give. We will improve our videos and the topics and some expression, some explanation. So your comments is very essential to improve our that is explanation and videos. Okay, thank you very much to watch my videos. Thank you. Thanks to all. Thank you. And please share these videos, or that is subscribe our channel, by which we will provide different questions. Okay, we will explain. I will explain most of the questions which are possible to define, design, and find the solution of different questions of computer organization and architecture. I try to level best to find out the different solutions of different questions of computer organization and architecture. Okay, thanks to all. Thanks.